Welcome, everyone. Thanks for joining us, and thanks for being part of our community. My name is Valan Kolika, and I'll be your host for today. Few reminders before starting the call. If you have issues viewing the stream at any time during this presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop version app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. During this time, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. However, in the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Sentinel forum at aka.ms/Azure Sentinel community. If you're listening to this after the fact as a recording, that's also a great place to ask questions. We love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security-webinar-feedback. And while you're there, please join our community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, and you can do that by signing up at aka.ms/security private preview. And while you're there, you can request features, give feedback, review our product roadmaps, attend in-person events, and hopefully that will be soon, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Ashwin will take us through threat hunting on AWS using Sentinel. Ashwin Patel is a senior program manager from our Sentinel team. And without further ado, I will turn it over to him. Ashwin, the floor is yours.
Thanks, Ron. Hello, everyone. So I'm very excited about today's session. So let's get started. All right. So before we start the actual agenda, I've got like couple of things to cover. The first one being, in case you have missed our previous webinars on RS announcements, we are running a AWS promotion through which you can import the AWS CloudTrail Logs through June 2020. So you can take benefit of this. Once you ingested the AWS CloudTrail Logs, you can basically use workbooks to get insight onto your AWS logs. Another thing that you can do is use the built-in queries and analytics and then enable on your AWS logs. There's a blog link that you can check for more details. All right, so these are the things that we are going to cover today. So we'll start with the introduction to AWS data sources, which you can use for threat hunting. For today's session, we'll be just focusing on the AWS CloudTrail. So we'll see how do we connect Azure Sentinel to AWS CloudTrail. Later on, we'll do a deep dive on the CloudTrail architecture, understand its schema, and then how do we use that for threat hunting. We'll also look into the MITRE attack framework use cases for AWS CloudTrail. So we'll take a look at the current Azure Sentinel detections and hunting queries. And lastly, we'll conclude the session with a demo on threat hunting on leaked access keys or compromised user. So before we start the AWS data sources discussions, since we are going to talk about two cloud data sources, we'll start with some of the basics. So Microsoft has done Azure for AWS Professionals documentation blog, which has a detailed information and one-to-one service comparisons, right? So we'll get started with like very basic architecture here. So for AWS, you have an account owner, and under that account owner, you have AWS resources such as compute, storage, etc. In case of Azure, you have an account admin. Under that account admin, you have a subscription, and under that subscription, you have a multiple resources. Now, in a typical enterprise environment, things can be a little complicated. You'll have multiple accounts, multiple subscriptions. So typically, the cloud provider will have a service to manage those multiple accounts centrally. So AWS has a cloud control tower, whereas Azure has Azure Lighthouse. So for today's session, we'll just take a look at some of the services comparisons, which are in relation to the Azure Sentinel or security data engineering pipeline.
Hey, Ashwin, sorry to stop you. If you can get closer to the mic, some folks cannot hear you well. Thank you.
Yeah, is it better now?
Yes, thank you.
Okay, so we'll take a look at the AWS to Azure service comparisons. So let's start with the EC2, the compute. So for AWS, we have an EC2, whereas in Azure, we have a VM. For storage, we have AWS has the S3, Azure has storage blob. For serverless computing, AWS has Lambda function, whereas Azure has Azure functions. For process workflow automation, AWS has a step function, Azure has logic apps. From identity piece, AWS has IAM and Azure has Active Directory. And from security point of view, AWS has Guard Duty, whereas Azure has ATP family, which is like multiple product offering such as Office 365 ATP, Defender ATP, Azure ATP, etc. Right? So there's more lists that you can check at the blog. I have included the link in the references section at the end, so you can check that. So now we are ready to talk about the AWS data sources. So these are some of the AWS core data sources that you can get started with. These covers multiple data sources. So right from CloudTrail has API logs, S3 access log has the file access level logs, the VPC and ELB has the network traffic logs, the Route 53 has DNS logs, and then Security Hub will have the actual security alerts. Now you can consider onboarding other data sources depending upon the use case or infrastructures that is currently deployed in your environment. Okay. So there are other data sources that you can consider, such as CloudWatch alarms, WAF, Web Application Firewall, Shield, or Messi. Now for these data sources, as you can see on the right-hand side, there's a preferred log destination. Most of these data sources support sending logs to the S3 bucket, and then CloudTrail also sends logs to the CloudTrail console, which has a 90 days retention. So we recently documented Schema and other relevant resources for each of these data sources, and actually contributed to one of the open source project called OSSIM. If you are not familiar with the OSSIM, it's basically open source security events metadata. It's a community-led project that focuses on the documentation and standardization of security event logs data from variety of data sources such as Windows, Sysmon, etc. So I have included a link as well in the references section that you can check for more details. All right, so for today's session, we'll just focus on the AWS CloudTrail. So this is the sample data pipeline can look like. The CloudTrail has two types of events. First, management events, and second is data events. So the example of management events can be your REST API logs and then responses that gets logged in the CloudTrail. The data events example is the S3 object level logs or Lambda function execution logs. Now, management events can be ingested directly via the built-in AWS CloudTrail connector. You also have an option. Probably use my. Okay, so for management events, you can directly ingest via built-in AWS CloudTrail connector, and you also have an option to send those logs to an S3 bucket, right? The data events can only go to the S3 bucket. So once the logs are stored in the S3 bucket, you have an option to ingest either through Logstash or Azure Function, right? If you are using a Logstash, you will use the S3 input plugin and then Log Analytics output plugin to send logs to the Azure Sentinel. If you are using Azure Functions, you'll have to use S3 API to read logs from the S3 bucket, and then use the data collector API to send logs to the Sentinel. So in both the cases, the logs will go into the custom logs table and not the AWS CloudTrail table. So in our previous webinars, Ofer has covered some of these ways, and then pros and cons of each of these approaches. All right, let's take a look at the CloudTrail architecture. So this is the diagram that AWS has published back in 2013 via blog. It has a very good overview of what's happening in the CloudTrail from an architecture perspective. There are some pieces that are not represented here, so I just added some of these details on the side. So let's start with the first layer. So you'll be accessing the AWS services via either the AWS Management Console or AWS SDK applications or AWS CLI, right? So we'll also talk about, like, while we cover these layers, like which events these information will get captured. So the first layer will get captured into the user agent field of the CloudTrail logs. The next one will be the AWS services that are actually used by these applications, right? So from these services, make sure that the services that you want to monitor is supported by CloudTrail. There are currently, as of March 2020, 159 total services that are supported by CloudTrail already. There are a couple of services that are not supported, such as Macy Trusted Advisor, or in case if your AWS service does not have a public API, that means that it will not be supported in the CloudTrail. Now, the next level is each of these AWS services will generate API or non-API events. So the example of API events will be create, describe, get, list, such as these APIs. For non-API, the examples are like service events or the console sign-in events. The CloudTrail Insights is something that you can enable while enabling the auditing. What it does basically is just analyze your CloudTrail logs and understand the API call rate patterns, and then calculate the baseline. And if your count is exceeded to that baseline, it will basically trigger an event, right? So coming back to the previous layer, this AWS service will get captured into the event source field. The type of event, the API calls or non-API, will be captured into the event type, and the actual event name will be captured into the event name field. So to summarize, we have an API which will generate the CloudTrail events. These will be enabled per region. You also have an option to create a trail which will basically cover multi-region and then centrally stored into the S3 bucket. So now we understood the architecture of AWS CloudTrail. Let's get into the schema of CloudTrail. So some of these fields we already covered into the previous slide. So let's talk about the highlighted fields here. So these fields highlighted in orange are basically have a nested JSON schema, right? So the user identity will have a static JSON schema, but the request parameter, response elements, additional events data, these fields will have a nested JSON schema, but it will change based on which API is being called by respective of AWS service. So it's very hard to document all of the schema in one go. The another thing that we need to note here is like for AWS services, the user agent will show as a typical AWS service name such as ec2.amazonaws.com. Couple of other fields that are important to consider is the error code and error message. So since we are logging the API requests for failed API responses, the error message, error code will be generated. So if you are enabling a detections for successful API responses, you can take benefit of these two fields. So let's take a quick look into the exploring the CloudTrail logs with the very basic KQL queries. So the first query is basically just retrieving the schema for the AWS CloudTrail. So there is a get schema operator that you can use to dump the schema for the AWS CloudTrail. So as you can notice, there are some minor differences from the original CloudTrail schema. So for each of the field names, the first character is capitalized. The another thing to notice here is the user identity field. Since I mentioned that user identity is a static, has a static schema, the schema is already expanded into a separate column. So you can utilize those directly into the KQL queries without JSON parsing. The next query here is going to show what services are currently logging into the CloudTrail. So the event source will capture the service name. So as you can see here, these are the services that are currently captured into the current CloudTrail logs. The next query is basically showing what are from where the API requests are originating. These are the IP addresses that are shown into the AWS CloudTrail logs to initiate the API requests. Let's cover a few more. So this is just summarize count by user agent. So the user agent will capture from which device you are trying to access or which application. So as I mentioned earlier, like the events that are coming from the AWS services will have the user agent as the AWS service names. So for example, console.amazon or signin.amazon. For rest of the user agents, you can try and understand like what type of application it is. So here we can say like there's a Visual Studio Code, or there may be AWS CLI or Boto 3 or things like that. The another query here is going to show aggregation from per AWS service, what type of event it has triggered and the actual API name. Here you can see that AWS API call is the type of API events, whereas the AWS console signing is the non-API events. Lastly, this is a little bit complicated, but very essential one. This will show AWS console logons with the MFA status along with the type of user. So as we mentioned, additional event data is a nested JSON field. So we'll be using a parse JSON operator to access the elements inside the additional event data. Here we are extracting the MFA used into the MFA used variable, and then just summarizing the time generated for the last login then. So the output here will show the type of user that has logged in last logged in timestamp along with the MFA status. So the MFA status yes and no will indicate if the type of user has used MFA or not. So let's start talk about the MITRE ATT&CK framework. So before we deep dive into the threat hunting, let's talk about the proactive detection approaches that you need to have. So if you are developing detections for the AWS cloud or in early stages, this is the good starting place. So the attack framework for cloud was introduced back in the October last year. So this basically shows the tactics and techniques for AWS service. So what we are trying to display here is basically attack navigator tool that will display the attack matrix, and then this JSON file has the filtering criteria that will filter just for the AWS platform. So these are the tactics and techniques that are applicable for the AWS services. Now this does not represent all the attack vectors, but it's a good starting point to go and start writing the detections. So some of these TTPs are not reflected here, but you can start utilizing these metrics. Now, before we write a custom detections, let's start understanding what are the built-in detections are available for AWS Guard Duty. So AWS Guard Duty has several alerts, which has names in the format of service name, the type of alert category, and then the alert name. So what I have done here is basically just pass those alert names into a structured data set and then visualize it here along with the default severity. So the color will indicate the default severity with each alert. Now the alerts are not directly mapped to the MITRE attack framework, but there are different categories are available which will give you an idea like what type of alert it is. Now Guard Duty alert utilizes both the AWS CloudTrail logs as well as the VPC flow logs. So you can see here there are like some detections which are based on the network traffic. So these alerts corresponds to the EC2 service. And then these are the alerts that are currently available for IAM user. The same like there are alert category as well as the different alert names, and then the alert severity associated with these things. Now coming back to the Azure Sentinel, so currently we have around 20-25 various AWS CloudTrail detections. So I've tried to visualize along with the attack framework tactics. So we are not trying to visualize the technique level, but this will give you an idea about like what type of alerts that are currently available in our public GitHub, and then how does it map across various attack tactics. Now we do have a detection as well as the hunting query. So what I'm trying to visualize here is the detections which has the severity associated with that low, medium, high, and then the blue one are highlighted with the for the hunting queries. Now as you can notice, like some of these alerts span across different tactics. That's because like the alert has a compound criteria which monitors on multiple API calls. So the multiple API calls fall under the various different tactics. There are also a few alerts. If we take example of this particular alert, which has a cross cloud. So if you are a customer who uses AWS along with the Azure AD, this is an interesting detections where you are basically looking for failed Azure AD logons followed by the successful logon on the AWS console. Now we'll cover a demo on the threat hunting on leaked access key or compromised user. So this is probably one of the common use cases that typically encounters in the enterprise environment. There are various reasons through which the access key for user can get accidentally leaked, either from developer or through some other means. So if we identify such scenario, how do we go about hunting that particular scenario? Now, before we deep dive into the Sentinel platform, let's try and understand like what we are trying to look for when we are doing the AWS threat hunting. Now we'll start with the alerts from the existing detection services. So if you have guard duty enabled, it will be a good idea to start with the what alerts has been triggered for the guard duty, as well as if you have some schedule alert for your SIEM platform to check like what alerts have been seen for that suspicious identity. The another thing that we can start looking at is what are the AWS services that has been touched for that particular entity. From the AWS services touch, you can try and narrow down the scope for which services and which API actions it has seen. And from the results, you can pivot your threat hunting criteria in various different ways. Some of the other methods are probably can also be fall under your existing detection program. So most of categories that are represented here are already monitored through public Sentinel community GitHub AWS CloudTrail detections. So if you have enabled those detections, you should be already covered with those scheduled rules. Another thing that we are looking for the API action is basically any APIs which are apart from list, describe, or recon activity. That these APIs will actually make changes to your resources or environment. If you are analyzing the logins, the one thing that you can start and understand is the type of user agent and the login activity pattern. So you can analyze the historical usage and then try and identify if there is an anomalous user agents that you have seen, which is historically not seen. The another crucial thing that you can look for is the assume role operations with roles which are having a high privileges. So this can be a typical method through which the attacker will try to escalate his privileges if he has access to those higher privilege roles. And then, as we discussed earlier, based on the AWS services touch, you can drill down your hunting to a specific API actions. If it is a EC2 service, try and see like if there are new instances were spun up or terminated. If it is a S3 buckets or like file level accesses, what files were accessed, if there are any deletes, or if there is transport of files either outside of AWS or within AWS to another cloud service or something like that. So now we'll move back to the AWS CloudTrail Azure Sentinel platform. All right, so we'll start with the first basic query, just retrieving the schema for the AWS CloudTrail. So the one thing that you'll probably notice here is the table name is slightly different than your built-in AWS CloudTrail. I have basically created a function so that I don't expose my account ID. So this function basically reads from the AWS CloudTrail table, but replaces my actual account ID with some fake account ID. Now we are starting with the hunt with the hypothesis that this particular access key ID is basically leaked into the public, right? So the first and foremost that you may want to see is like which user this access key belongs. So you can just do a like search across your CloudTrail logs and then distinct user identity ARN for and then username. So if you execute this query, this will basically output the username for that particular access key ID. Right. So this is the ARN, the account ID, which is I've basically replaced and obfuscated. So let's try and understand like what all API activities that we have seen from that specific user. So what we are trying to do here is like summarize count by event source and event name. All right, so let's sort by the time generated. So you can see that there are multiple event names that we are seeing, describe instances, list instances. There are some APIs that you can see which are actually going to make some changes in your AWS resources, such as remove role, add role, create key pair. There are followed by some recon API calls. There's a run instance. There's also a delete instance. So now you have a little bit of idea like what API actions that we have seen from that particular user. So let's try and pivot to a specific API and understand what's going on. One other thing that you can do is like in a typical enterprise environment, you will have like a lot of noise. So if you want to filter out the recon type of API names, you can just use this query, which will filter out the APIs which starts with list, describe, get, or lookup. Now let's start with the remove role and add role and try and see like what is happening here. All right, so this is written two results. So let's try to navigate here. What is the request parameter passed here? So as you can see, for the remove role, this particular role was removed from this particular instance profile. So the instance profile is normally associated with your EC2 host, and then these particular profile privileges are automatically assigned to that particular EC2 host. Let's see what was the next event here. So we are looking at the add role to instance. The user Kerrigan has made this change. So here we can see that for the same instance profile, the new role has been added. So this is an existing role that is added to this particular instance profile. So now we can start and pivot our threat hunting to this particular role. One of the other things that you can do is like as you find out the interesting events, you can click on these events and then start adding a bookmark. I've already added these bookmarks, so I'll just skip this step. So now let's start move around for this particular role. So the next query is basically looking for that particular role in a request parameters. So this has written a number of results. So I have already sorted the results by time generated. So I'll have the first event, which is actually the create role event. So let's see like who has created this role and what does it contains. So you can see that the user CloudGuard has created this particular role. So CloudGuard is attack simulation framework. So let's, for the time being, let's ignore like what is the identity that has created this role, and then understand what was the request parameter. So if you navigate to the request parameters, you can see that this role has created, which has the permissions for Azure role from an EC2 instance. So nothing suspicious so far. What we are seeing is that this role will have can Azure role from an EC2 instance. Now there are like other APIs here. The next one is the attach role policy. So let's see like which policy is attached to this particular role. So if you navigate to the request parameters, you can see that there is a policy CGEC2 mighty policy was attached to this particular role, right? So now we can pivot our threat hunting to this particular policy and try understand like what permission was having to that particular policy. Now we'll do a similar search, but in this case we'll just do a search for the policy. All right, similar to role that we have create policy. So the same user has created this particular policy. Let's navigate to the request parameters. Try and see like what is the policy says. Okay, so this is interesting. So what this policy indicates here is the any action is allowed for on any resource. So this is suspicious. This basically allows administrative roles for this particular policy. So this policy is basically administrative policy, and if it is attached to any particular role, that role can do admin level operations from any instance. So we know that when we started our initial hunt from the specific role which was attached to the EC2 instance profile, the policy indicated that that role is a high privilege role. So another operations that we saw in the initial results was there was a create key pair. So let's see for this specific event. All right, so there are two key pair events. If we go to the request parameters, so one of the other things that you can do is basically project the relevant columns. Since the event names, since the results are very small in my session, I'm just navigating to the individual events. But if you are working through the actual event logs, you will have like a lot of logs. So try and project what are the relevant columns that you want. So here we can see that there was a key was created, which was named as Kerrigan. And then in another event that we can see, we have another key, which is pawn. All right. Now create key operation is not suspicious in its nature. So let's try and understand what are the instances that were spun up from that particular user. So we can see that there are two instances were spun up. Go to the instance. So you can see that this instance was attached with that instance profile, which was the high privilege one. And then there are other details such as image ID, and then the response for this particular event. So in the response column, you will have some additional details for this instance, such as the instance ID that is created. Then there is a DNS name for that particular host, and then what key was used for that particular instance. So you can see that the keys that were created, by using those keys, the new instances were spun up. Right? Similar case for the other one here. So we have another EC2 instance created here, which is using the key name Kerrigan, and this is the DNS name. So we are still exploring these logs and then trying to understand the full picture here. And then we'll summarize shortly what is happening. We have still not identified what is the final goal for the attacker. Now we'll just move away from this particular user and then see all activity that has happened from this particular high privilege role. Right. So from these role, you can see that there are these 4 events has been triggered. Couple of them are just the describe instances, but the last one is the terminate instance. So this is an interesting. Let's navigate here. So we can see that from these high privilege users, terminate instance operations were conducted. So let's see. So this particular instance ID was terminated. Now, one of the things that I did was in previous query was capture the instance ID that were spin up with those usernames. So this instance is different than the previous instances that were spun up. So that means that this is an internal instance that were terminated from your internal infrastructure. So you can go back and see from your asset inventory what that instance, or from the CloudTrail logs, what that asset instance belongs to, right? So it could be asset which is super critical in your environment, which has been terminated down by adversary. So now you understand the goal for this particular attacker, that he basically started with the, or let me go back to my slide, which has more. All right, so this is the interesting timeline, events timeline. So we started with the create role, create policy. Then we saw the policy which was having the administrative level permissions was attached to a specific role. This role was then attached to a specific instance profile. And then by using this instance profile, a new EC2 instances were spun up, right? And then from that particular instance, a new instance was terminated. Now this gives a good overview of what has happened in our typical attacker scenario. So the attacker basically started with the Kerrigan IAM profile. This was basically leaked into the public. This particular user itself did not have privilege roles, but what it did, it has a particular permission through which it was able to pass the IAM. It was able to swap the IAM instance profile. So with this, starting with this IAM profile, it started identifying what are the pre-existing IAM instance profiles, and then it identified the IAM role which has the full admin policy attached at this particular timestamp, and then it basically swapped the full admin role onto the existing IAM profile with the remove role and add role, and then it created an EC2 key pair which has identified through that create key pair. The last one is the create new EC2 instance with that key pair, which was the run instance attached to that particular key pair. We also saw that this particular event has associated the IAM instance profile, right? So you can see that attach full instance IAM instance profile to that new EC2 instance. And then lastly, the attacker basically accessed that new EC2 instance via SSH and then terminated your supercritical security server, which was the final goal for the attacker. Now this gave a little bit of glimpse into how you can start conducting your threat hunting operation on AWS CloudTrail Logs. There are various, so from one of the things that we can do from our threat hunting exercise is, once you identify a key criteria, start creating threat hunting queries or detections from that exercise, and then onboard to your detection platform. So that concludes my demo. A little bit of call up actions at the end. Please join our growing threat hunters community for more updates. You can follow these links, http://ak.ms Azure Sentinel Threat Hunters. You can always opt out if you do not find the content relevant, but there's a vibrant growing community out there through which you can get updated on various resources for the Sentinel features and materials. These are some of the resources that we covered in the into the session. So there's a AWS for Azure Professional blogs, starting with the AWS CloudTrail user guide. The OS theme, this is the reference to the pull request that we made, which has the documentation for AWS Cloud Data Sources, the Cloud Guard duty active finding types, and then the Cloud Guard scenario IAM privilege escalation. So that's it about for today's session. We'll give it back to the Balan.
Thank you, Ashwin. Yes, we do have some questions, although most of them were answered by the team, and thanks for that. So what is the best way to ingest the CloudTrail logs into Azure Sentinel with AWS permission?
Yeah, so the slide that we covered earlier, we have a AWS built-in connector that supports ingesting the management events. So if you're logging the management events, you should be covered through the built-in CloudTrail connector. But if you want to ingest the data events, so the example of data events are the S3 object level logs or Lambda execution logs. So if you're not trying to ingest those logs, then you should be covered through the built-in CloudTrail connector.
Great, thanks for that. Another question is, can I send logs through VPN gateways between AWS and Azure? And should I use Sentinel private IP or Log Analytics private IP?
I think this probably may require some additional discussions, understanding the architecture. So I would advise to post it to our tech community discussions, and then we can start an answer in more detail.
Well, this is Shane. I can answer a little bit.
Yeah.
So I did post the kind of an answer to the question in the chat. Apologies, I was having problems with it posting for me, so I had to log out and log back in. But there is site-to-site VPN gateway. There is some third-party documentation on how you can do this between Azure and AWS. It's readily available. I found lots of items on that. I'm not an expert in the VPN gateway area, but it was pretty easy to find. The one comment is the HTTPS is the log ingestion connection method. So a VPN may not be necessary depending on your requirements. So just got to look at it from that perspective.
Thank you, both Ashwin and Shane. Great. And another one, which is probably the last one for now, using analytics and logs at real time, does it generate real-time advisories from where a possible breach can happen?
So from the Sentinel itself, there are no threat advisories, but there are other Microsoft products that can provide the threat advisories.
Okay, great. Thank you. So we'll just, before we recap here, before we end the call, sorry, we'll just some reminders for the upcoming webinars. So our next scheduled webinar is on May 13. This is using Sigma to accelerate your SIEM transformation to Azure Sentinel. And then for the save the date, we have the following in the pipeline. On June 2nd, we have learn the KQL you need for Azure Sentinel. And then June 15, we have deploying and managing Azure Sentinel as code. And then on June 23rd, we have multi-tenant investigation. And for details and registration, please visit us on aka.ms/security webinars. This is one of the links that I had posted at the opening of the webinar. And in case we missed to answer your question, or if you have additional questions, you can visit us on our Azure Sentinel forum at aka.ms/Azure Sentinel community. Thank you, Ashwin, for a phenomenal presentation. Thank you to the rest of the team who helped answering the questions. And most of all, I want to thank you for being part of our community and for joining us on these webinars. And we hope to see you next time. Goodbye.